Hey, hi all. Once again, welcome to Mathematics Mania YouTube channel. And in this video, we will see nth derivative of exponential function. So we have already seen few of the nth derivatives for algebraic functions, and we solved it using the partial fractions in our previous videos. Yeah, in this video, let's go and explore finding the nth derivative of exponential function. So let's take an exponential function here. So let y equal to a raised to mx. Yeah, a is a constant here and m is also a constant again. X is a variable. Yeah, let's start differentiating the given function y with respect to x. So y1 will be, so we know that the derivative of a raised to x is a raised to x itself into log a. That is the exponential rule of differentiation. So what happens here? So a raised to mx is a raised to mx itself, a raised to mx into, applying the chain rule, and we log a, applying the chain rule, the derivative of mx. So the coefficient of x is m here, so it will be m, that will be equal to m into a raised to mx into log a. So this is y1. So again differentiating with respect to x again, y2 will be equal to, so here m is a constant and log a is also constant, so we are left with a raised to mx again. So what happens? M into a raised to mx is a raised to mx itself into log a. Log a, already a log a is there, so now it will become log a the whole square into chain rule, the derivative of mx, that is the coefficient of x is m here, so that will become m, so that will be equal to m square into a raised to mx into log a the whole square. So that is y2, and let's see what is y3. So y3 will be equal to, here m square and log a the whole square is a constant. Again we will take the derivative of a raised to mx, so the same thing holds good here also. So m square will remain as it is, and a raised to mx is a raised to mx itself into log a. Log a square is there, so this will become log a the whole cube, because log a into log a square is log a whole cube, into derivative of mx is m, so that will become m square into m will become m cube into a raised to mx into log a raised to 3. So and so on, we will get y derivative, the nth derivative of the function y. So let's have a look here. So when y1 was there, we have m raised to 1, a raised to mx and log a. Log a is nothing but log a raised to 1. And when we have y2, it is m square a raised to mx into log a square. So m cube a raised to mx into log a cube for y3. So for yn it will become m raised to n into a raised to mx into log a raised to n, implies yn will be equal to m raised to n into this constant, we will take it this side, log a raised to n into a raised to mx, which is the nth derivative of given function y is equal to a raised to mx. So now we will see, we will just replace this a by e. So now let's see that. Now let's replace a by e. So what happens? This implies that yn will be equal to m raised to n will be m raised to n itself into log of a. A will be replaced by e, so log of e raised to n into here a will be replaced by e, so e raised to mx, that is for y is equal to e raised to mx I am taking. If I am taking for y is equal to e raised to mx, that is y is equal to e raised to mx. If I am taking the derivative of y is equal to e raised to mx, what happens we will see here. So m raised to n is a constant, it will remain as it is. So log a and e, one is the inverse of each other, so they will cancel out each other, so that will become minus 1 raised to n into e raised to mx, 1 raised to n itself, so m raised to n into e raised to mx. So yn of e raised to mx is, will be nth derivative of e raised to mx will be given by m raised to n into e raised to mx. So this is the derivative of exponential function, and now we will see a small example to that is corresponding to this exponential. So let's say find the nth derivative of e raised to x into x. So here y is equal to e power x into x. So here y is equal to e power into x, so we have two functions, so we will have to apply the product rule here. So what happens, y1 will be equal to first function, that is, let's take e raised to x as first function and x as the second function. So first function into derivative of the second function, that is 1, plus second function, that is x, into the derivative of e raised to x is e raised to x itself. So that will be equal to e power x plus x e power x, which can be written as, let's take e power x outside, so it will become 1 plus x. So this is y1. So again differentiating the y1 with respect to x, again we will get y2. So y2 is nothing but, so e power x is there, so derivative of e power x is e power x itself, plus if you see the derivative of x power ex, so we already saw the derivative of x power ex is nothing but e power x plus x e power x, right? So one extra e power x is there that I have written here. So the derivative of e power x is e power x, plus we have to take the derivative of x into e power x, which is y itself, right? So that will become e power x plus x into e power x, that is nothing but, so we have 2 e power x here, so e power x plus e power x is nothing but 2 e power x plus x into e power x. Let's take e power x outside, so this will become 2 plus x. So now let's see y3. So when we take y3, so we have 2 e power x here, so let's take 2 into the derivative of e power x is again e power x itself, so plus again x e power x, the derivative of x e power x is nothing but e power x plus x into e power x, so that is e power x plus x into e power x, that is nothing but 2 e power x plus e power x is 3 e power x plus x into e power x. So let me take the e power x outside, so what will remain here, 3 plus x, and so on. Let's see what is yn. So if we carefully observe here, when we were taking the first order derivative y1, so e power x into 1 plus x, when we taking y2 it is e power x into 2 plus x, y3 when we were taking e power x into 3 plus x, so now yn is nothing but e power x, and here in place of 3, I mean when it is y3 it is 3, so now this will become n plus x, which is the required nth derivative of y is equal to e power x. So suppose if there is a coefficient in this m, so that way we will have to write it here as it is. Yeah, thank you for watching. So let me know if you have any questions. Yeah, so let's meet in the next video. Thank you all. Bye.